feel free to, join in the conversation. I do like a lot of feedback. I mean, I don't feel so lonely up here talking. But I got to thinking back on, the class and I didn't do anything to pull all the weeks together. So kind of feel bad about that. And that's why I wanted to do this video, to basically go through the whole process and to bring it all together in a concept. So that's why we're here. I still don't hear anybody, but I guess if you can hear me, we'll go ahead and continue. I'm going to try not to get sidetracked. I'm going to try to stay focused on doing basically this specific thing, is to pulling all the lessons together and just to show you how it's done. And basically an example of the BFE proficiency. So I've created a project or directory for it. Just here, I called it Walkthrough. So I'm going to start there, and it's empty. And it's empty because I'm just going to use, what I have available from the previous classes. I do a lot of preparation sometimes, but this time it's going to be really spontaneous. It's using all the, the data that we've collected, all the previous classes, basically. And I'm just going to go through it. And I'm going to start with the very beginning with basically a brand new blank QGIS project file. So here we go. It's awful speedy. So it's blank. And, when we started, I set a lot of settings in the under the properties, and I'm using those same ones basically from the class: relative links, map units, and so forth, feet, square feet. The same with the settings under options. This is the same way I set it up all the time, basically. So we're going to be starting with that, and it's totally blank. So before you start even doing a BFE, there is files that we've established for our project area, which is Cabell County, that facilitates that process. So the first thing I'm going to do is start loading them in here. Let me go to my data directory. So, wow, before I do that, let me do one thing. I'm going to download the worksheet file from the class materials. Let's see where I put that at. This right here, because remember I said that basically just leads us through the process. So I'm just going to download it. And generally that puts it in the download directory. I'm just going to cut that. I'm going to put that right here. And so the very first thing we do in this example, I'm going to go back and zero these out. They shouldn't actually have any data in them. So I think there's something wrong with I don't know. I think there's something wrong because I can't hear nothing. That's bothering me, but I'm going to keep going. So the first thing we want to do is the drainage area. And so, the things that we created and manipulated to do that were the DEMs, the DEM of the county. I'm going to shut that and we're going to zoom in on it. I like making it look good as we go. So there is I'm not seeing it. No data value. That's what I want. Changing that to 0. There we go. I was going to say I didn't apply it. Okay, that's it. I'm going to save it. I have a habit of clicking the save button the whole time, and I haven't saved this file yet. So I'm going to do that. And I always just call them QGIS. So I saved that to my project directory. Now this isn't saved to my project directory. So, keep that in mind. What we're doing right now is just calculating the BFE. I'm not submitting the project yet. I'm calculating the BFE. And the way we do that is to begin with calculating the basin. Well, I've actually attached the DEM, and we don't use the DEM to calculate the basin. This is actually for the cross section. But I'm going to go now. I'm going to load up the layers that we use to calculate the basin, which is the streams. The streams and the direction layer. So this is what we use, streams and direction layer. I'm going to turn them off. And then, so since I'm looking at all the data that I use for reference, there's a couple more things. Then there's the land cover, land use, land cover. I don't know if I made a small one of that. I don't think I did because everybody was actually pulling in the whole state. So let's just bring in the whole state right here. Land use, land cover. I'm going to go ahead and add the symbology because it's the symbology layer that helps us select the Manning's N values. Yep, that's it. I'm going to change that change the transparency on that one. Okay, so what else do we need? Now I'd like to use the NFHL, so I'm going to go ahead and connect to that. The flood boundaries. And the zones. And then I'm going to add Google Maps too, because I want to know where I'm at. Can't tell where I'm at. I could attach the county though too. I'm going to make these transparent. Actually, that's the boundaries. I don't need those to be transparent. I need the flood zones to be transparent. Okay, so we're almost there now. Let me think. Directions, streams. Okay, so I'm going to also add let's see if I can find it on here. It's probably in my one of my weak directories. And I didn't put a lot of emphasis on it, but what I'm looking for here is the georeferencing map where it might be this one. That's I think that's it right there. You can see the importance of naming your file something that you can recognize. Didn't recognize that, but I'm gonna put that on there too, just as a good example. Turn that off. You know, I can't stand it. I'm gonna put the county layer on there. It just bothers me that I can't see the counties. Okay, so I think we're kind of ready to go. You know, the assignment is to pick a location and to calculate a BFE. You know, that location has specific recommendations like be a straight part of the stream and so forth. So I think we're ready. I think we have everything that we need to do it, comfortably. And let's get started. So the first thing I want to do is zoom in far enough to see all the zone A's. So when you're looking for zone A's, these areas here that show like this striped area that's also highlighted as a flood zone, that's what we call a floodway. And a floodway generally is only designated in zone AE areas, which means it's a detailed study. So the areas that we're looking for are actually, little areas like this that just show blue. And you can see that there's a number of these across the county. But then you can also see these, this flood zone area and the possibility that it is a zone AE. Now you can see this line right here in the boundary. If I zoom into that, this is a zone AE right here. And then based on this straight line, this area turns into a zone A. And they do that. I mean, that is how their mapping standards are done. This is part of a detailed studied area that uses cross sections. And then this zone A over here, these are actually surveyed cross sections that they use in this zone AE. Well, on the zone A's, they use basically cross sections that are created from the digital elevation model, much the same way that we're doing. So here's an area. This is an area that possibly, you could select a BFE on, at least based on the directions and guidance that we gave in the assignment. So I'm going to turn on the streams, and you can see, now you can see the streams. And one of the criteria too was, you know, I didn't want you to pick a cross section like in one of these areas here that shows a convergence of the streams. It just makes it more difficult. I mean, you have to figure out how to place the cross section, and you know that just comes with experience and with how to do that. And we didn't really focus on that in this class. A lot of the classes I've taught in the past were with people who had more experience in GIS, and we went through days of looking at these different situations and how to place cross sections. So I didn't want that to be the case here. I wanted it to be easy. So I'm going to keep looking. I'm kind of looking for a specific area that I've looked at in the past. I probably won't find it. So I'm probably wasting my time. So I think I'm just gonna go right there and choose an area right here. I think I'm gonna do this area right here. So let me turn these off. I want to look at the topography a little bit better. See if we got a better one than that. Terrain. That same one. Wasn't much there, was there? Not much. But what I really wanted to do is make sure I identify the creek. You know, the creek is in here. Hard to see sometimes with the aerial photography. That's why I like to use the West Virginia imagery, because it has leaves off. That ends up being a big deal. West Virginia transformation. Can't see it too much better, but there is a little bit more indication. I can see it really good, like right here. It looks like it comes through the trees here, you know, and it goes this way. Yeah, this looks like a really good spot. So I'm just going to make something up, you know. I'm going to say, I'm going to create my shapefile for this area right here. It's going to be a point shapefile. And I generally call them location. So there's nothing in this, you know, I'm just identifying my BFE where I've decided to do the BFE. And, you know, the idea is here, where am I going to put it? Okay, so somebody called in, they got this nice open property, they want to build a new structure. Where do they think they want to put this house? And, you know, most of the time they want to put it really close to the creek. So I'm just going to say, hey, they want to put it right here. So that's where we're going to do this thing. That's where we're going to calculate a BFE. So now we got the location. And so the next thing is, according to our worksheet, we got our location. It is what? It's the basin. Calculate the basin square miles. And there's a couple things going on there when we do this, especially by this spreadsheet, because we do the drainage basin real quick, and then we jump into the elevations up and downstream. So just keep that in mind. So the first thing is the basin. We do that with the streams. And basically we pick a line perpendicular to the stream, you know, so in this case, it looks like I got it right in the middle of this square. So does it matter which one? Well, you know, it can. But most of the time, what I try to do is make it conservative. We'll just call it conservative. I'm going to turn on the flood hazard layer because what I want to know is which direction is this flow going. And so the basin's going to be up in this direction. So the flow is this way. So I'm going to pick this, you know, this looks like I would typically want to pick a point right here, you know, because it has to be on these squares to calculate the basin. But this time I'm going to pick this one that's the little bit furthest downstream. And I'm going to bring up our models that we created in class. Basin square miles is the biggest one. The direction layer right here, and the stream point right there. So I just picked in the center of that square because, you know, that's what it's being based on. It's being based on that raster cell. I hope this is recording and it's getting sound. So now we're just going to calculate the basin using our tool we created previously. And I always do basin 0, 1 because I might want to check out another one and call it basin 0, 2. So I always just start it with a 0, 1. So this is the basin layer. It's doing all the basin function, or what we call it, model tool. It's calculating the area using the direction layer. It's using that point that coincides with that same direction layer. And then it's putting the attributes. It's calculating the area in square miles. And in this case, it's adding the QML what we call it, style to it also, because that's the way we set it up. So we got that done. So I'm going to turn these off. Don't really need a lot of that stuff anymore. You know, when I do this regularly, I group these things, and if I don't, you know, in groups, and then turn them on and off as I need them. So, you know, this isn't set up that organized, but that's how I would generally do it. So here we're going. Now this is awesome because now we pull up our worksheet, put in our value, 1.43 square miles. So now we know next thing is put in the cross sections, because that's the next step in the worksheet. And we know what direction we're going now because, you know, for one, we've done the basin 2 and the text is on this side, but we know the flow is this way. So the cross sections are always put left to right. So one of the things I want to do before I do the cross sections, though, is I want to create contour files from the DEM. So our DEM in this case is the DEM 3 meter 3 feet is what I got called. I want to draw an extent on canvas of where I want it to calculate. And I just need that immediate area. And I want the interval, and I mentioned to put this default in there in the model. I haven't done that, but you want to make sure you put a value in there, and I always want it to be 1. So I should change that to 1. And I'm going to save to my directory walkthrough. It's going to be called contours. And so the value of the contours is that it actually lets me see where the floodplain could be, because you want your cross section to completely cover the floodplain. You want it to. You don't want a short, and it can happen. You can get a short cross section, and it cannot be. And sometimes, you know, it might not be big enough, but you don't want that. You want a cross section that is long enough. So that's what you're doing when you're looking at these contours. So they show the floodplain boundary here in the old zone A. See how it doesn't match real good? See how it comes up on this hill, and over here it doesn't come far enough. And kind of the same way on this side. It doesn't really, you can tell that this wasn't the digital elevation model that was used for doing this mapping. It just wasn't. And plus we can see our stream here a little bit better, you know, at least as it, you know, appears as symbols on contour lines. You can, you know, the banks are starting to, it shows where the banks are. And this is what the cross section is going to be created from. It's not, you know, from the aerial photography, even though we use that. You know, you can see this little area over, no, that's not what I wanted to click on. This little area over here, you know, it's like, what is that? You know, it's aerial photography. You can see some trees that don't have leaves on it, and it makes things look fuzzy. But if we look at the contours, oh, we can see that that's like a low area where the creek, you know, might come out of its banks pretty readily, or its banks aren't as well defined. But anyway, what we're going to do, based using the contours and using the flood hazard zones, I'm going to create a cross-section file. This says WGS84. I don't remember what I did the other ones at, but I should have. I'm going to have to check that because it should have been UTM Zone 17. In this case, this one wasn't, but I had to change it right here. So we're going to make a line, and it's going to be the cross sections, and I'm in the right directory. I always just call these XS. Let me see what my basin. Oh, it says unknown. I'm going to fix that right now. See what my location is. WGS 84. I'm going to keep that WGS 84 because most of the times when we're doing coordinates, like I talked about coordinate and point data being really portable, WGS 84 is really portable. I'm just going to keep that as WGS 84. If it was UTM Zone 17, I don't think that's a problem either. So, but I regularly just maintain points as WGS 84. It's what Google uses. It's what all the map portals use. So I think it's a good choice. Okay, so let's put cross sections. Put my line in. I want it to go right through that point. I want it to go across this creek. And I want it to go a little bit beyond, you know, basically the floodplain. I want to identify the entirety of the floodplain. So I'm going to actually take this all the way up to here where these contours start sloping up also. You know, and if I had my elevations turned on, I could actually see what those numbers are and see how they correlate to each other and how the relation to each of them are on each side of the creek. Oh, I did the wrong. That was the wrong one. I was wondering where my elevation went. So this gives me a little bit better idea if I was to turn them on. I mean, over here, I'm going up into like 602, and look, I actually hit the same. It's the same on the other side. And I have to tell you, that was just pure dumb luck. That's, you know, I've done this so long. That is definitely nothing other than that. But I'm going to turn the contours off now. I'm going to turn off the image. I'm going to turn back on the terrain. And basically, the second one, the second cross section, I just want it to be a minimum of 100 foot upstream. So I want to measure that. So you can see 100 foot comes very quickly. And this is, it looks to be, you know, a pretty flat area. Each one of these lines crossing the creek in this case is a foot, you know, so if it's really flat, you might have to go further upstream. This case, I'm just going to put it right here because this is, I don't know, I don't like that area. This looks like it might have more of a channel right here, and that's what I like to see. So I'm going to place it right there. Look, I did it wrong. That was in the contours. I selected the wrong thing previously. Okay, so here we go. Try it again. Now, one of the things I want to point out too is, let me just place you another thing here. I changed that symbology in one of my presentations. And, you know, I used it as default for a long time, but you know what? I couldn't see it. And that's why I changed it. I wanted it to be a little bit heavier and I wanted to be able to see what it is, this idea of seeing the temporary line. So if it looks different than yours, that's why. But basically we're done now with those cross sections. And I'm going to turn off the contours too. I'm going to turn off the basin. And I'm going to go back to so we're doing elevation up and downstream now. So let's pull up the profile tool. We're going to put in our DEM layer and we're going to select the line for the, so we can calculate the slope. Upstream, 587.1. Downstream, 584.1. And then we measure the distance. Now, I like to use the aerial photography. And then in this case, I'm going to turn the contours back on again. Wrong aerial photography. And I think in this case, these contours really help to stay, you know, inside where we think the stream is. However, you may want to choose your snapping options because if it's turned on, it doesn't let you place a, you know, it might snap to the line when you don't want to. So I usually turn mine off. So the snapping options are under project snapping options, and mine's turned off right now. So what that lets me do is go to measure line. I'm measuring feet. I want to start right here in the middle. I'm going to measure down what looks to be the middle of the contour lines, all the way down to the cross section. 303.8. So that's our slope. The next thing is our Manning's N values. So we're looking on the left and right side of this channel. So on the left, all we know based on the aerial photography that that's all trees. So this zone, it's going to be, when we select on it, it's going to be forest. So we know the left's going to be .41 or 0.16. But the right, it's not as easy. There's a couple values over here. And this one of the things that I'm going to show you in the future is, a lot of these have the same value. So, whether it's this or this, it probably doesn't matter that much. Based on what I'm used to seeing, one of these is open space and the other one is maybe, well, here it is, pasture and hay. And then this yellowish one, I think it's kind of the same color here. It's called grassland. And then this one that starts getting into like urbanized areas, like developed open space and so forth. So you have to pick one because, it's obvious that this isn't urban. So I would not use that. Anything in these red categories. If it was up by the road, maybe, or if it was at this house, probably. But this is out in this open field. So it's going to be for me one of these two. So let's just check them to see what they look like and see what their values are. See if they are the same according to their Manning's in values. This one says 71. And this one says 81. 71 is grassland and 81 is pasture and hay. So they do show a little bit of a difference here, but not by much. Pasture and hay is 30 and grassland is 0.035 and this one's 0.030. So, man, they really break it down on these Manning's in value. So what did we say it was? Grassland. This one's 81, pasture and hay. So I don't think it's that. I think it's more grassland, so 0.035. Oh, and it rounds off to 0.04. And I think that's good enough. I mean, that's typically what I use. It looks like it rounded it up anyway, so I think we're good there. So now we come down to the Nss calculation, and we know we're in West Virginia, and for the state, the Crippen and Blue region is 4. So the next thing is the state region. And you know what? I just find myself always checking that because, I'm not always working in the same county, not always working in the same state. So I basically, every time, I mean, I'm doing it for across a number of states. So I want to make sure that I get in the habit of checking that. I don't care if I think I know what it is. I want to know what it is. And the way we do that is to check it. So there it is. No doubt. This is the map from the report that we geo-referenced, and it shows that this light colored area is the Western Plateau. This is the central and this is the eastern. So we're in the western part of the state region. So man, we're moving right along. Let's see what's next. Okay, we got to calculate the discharge, and we do that by using the Nss program. Now, where did I put that? I put it here. I think so. So I'm going to start off with a new one. We're in West Virginia. I'm going to select new. We know we're in the western part of the state, and if I look at our map, West Virginia most of the time is in the Region 4 for the Crippen and Boo 77 report, and then our mileage goes up here, or square miles, square mileage. And what was that? Let's see, 1.43. 1.43. We hit OK. And here's the results. Our discharge for the return value of 100-year or 1% annual chance is this value right here. PK 100, 709. So 709 is our discharge value. And that's measured in square feet per second. Square feet per second. Actually, yeah, that's feet cubed per second. So 709, important value. That's what's going to get our volume. That's what we're measuring the volume from. So now from our channel, you know, we're given that volume of water shape, and that's what we're measuring, the volume of that water in the channel. I think it's pretty cool stuff. So I'm going to capture this because that's part of my records. This is part of, you know, the files that I've asked for to see. Because when I check it, I'm going to check the results. You know, you're going to go through the steps. I'm checking the results. So I'm just going to save this to the folder. There's a lot of screen captures out there. I use this one. Windows has one built in. And I always call them, I just call this NSS. So in every one of my folders, I'll have a file called NSS, and it will be this screen capture from the actual program where I calculated it. And when I check it, I'll be checking it against the spreadsheet right here, 709, PK 100, 709. So that's what I want to see. Okay, so we're almost there. I mean, look at this. We got everything filled in. Now we have to go to the cross sections. I don't know. I don't like that the thing that I put out there had numbers in it. I don't like that at all. So now we're going back to our project file. We're going to go zoom back to our project area. We're going to do the cross sections, and we're going to pull the cross sections off of the DEM by selecting the polyline. And then by going into the table, copy to clipboard, and pasting those values here. So we're in good shape. It's 26. There's a limit of 40 points, so we don't have to do anything with this one. But that's what these values are for, is to kind of help you thin out those points if you need to. It rounds them off to the nearest foot, so you can get rid of, like, here's a really good example. So if we round it off to a foot, it's really flat right here. So I would actually pick in between those, and I could delete those points if I wanted to. I'm not going to do it in this example because I don't need to delete points. And then I usually get rid of these too because I think they're in the way if I'm not going to use them. So I'm going to insert a chart now because I want to see and I want to identify basically the banks. So man, this one, not much of a bank on this one here. So gosh, I'm just going to have to put the bank here. And then the other one, yeah, not much of a bank on that one either. I mean, I think it's either going to be these two. And you know, the real value of this, and I want to explain what this is doing. I'm just going to pick this one, 16.8. because this is where the Manning's N values are applied. The channel is 0.04, and then everything on the right is going to be what we put for the value on the right, and then everything on the left is the value on the left. Well, in this case, the left's not even going to get calculated other than, right here, because we don't have one. So that's part of the math, and that's part of the overall functionality of it. Typically, there is more of a bank on either side, and that's, we selected a Manning's N value to be applied to those overbank areas. In this case, everything here up here has a different flow rate than what's in the channel, if they're different. See, we're saying the left has a different flow rate, but in our case now, the flow rate of the channel is basically the same as the overbank. So that's just part of it, just part of the details. So now we go to our next tab, where we're formatting the text file that's going to go into the Quick 2. And let's see if this formula, we know that's not right, so we have to count them. 5, 10, 15, 20, 25. Okay, so 25 stations, so we need to change that to 25. Left station in this case is 0. Right station is a lot of points, so I'm going to copy that, because you have to put it in exactly the same way. Basically, you're matching what's down here. So the left is 0. I want to make sure that what that looks like, and this looks like. Match, 25. I like things to be clean and neat, so I'll delete what we're not using. Save this, copy it, and then go to our directory where we have our project. Actually, yeah, I'm going to do it here. So this is called xsec.xsc without the text. And I've associated Notepad with mine, and this is where we paste it. And then save. If you don't have it associated, you can, and I always do this anyway because I like having it handy, but you could just open Notepad and drop it in there and then save it if you don't have it associated. But we do, and it's there. I'm going to copy it. I'm going to go to my Quick 2 directory that's in C. I'm going to be overwriting this one from a previous class, so I'm going to get rid of these because I don't want to confuse myself. So now I'm going to start the program. DOS box launches the Quick 2. I'm going to select number 3, normal depth, irregular channel, F6, C, no subdirectory, file name, XSEC. And I usually check to see that it matches these points, 5971, 0, and then at least the first and last. So it looks like everything's right. So now I have to enter the slope. So I'm going to toggle my numblock button, and then I'm going to type in the slope from page 1. 0.00 987 491 8. Now, somebody told me you don't have to type all those in because it rounds up. It does, but I type it in every time. Just what I do. So hit enter to calculate, or enter to enter the slope value, and then hit enter again to calculate. And there we have it. So our BFE is right there, 589.96. And the flow is subcritical. And is that all we need? I think that's it. Look how the depth is right here. This is what you're calculating, is the volume of the channel. This is the area, the top width, 31 feet, because this, we know everything's in feet. So what I'm going to do is capture that. And that's what I'm going to use from you to, you know, when I open up your files and look at them, is I'm going to make sure all these values match. I always call that quick two reference. So basically we're done now. The BFE is 589.96. And what I usually do in my project file is I always want to see where that's at. So I'm going to turn on my flood hazard boundaries. We'll clean this up so I can make a, I'm going to turn on our satellite, and I'm going to take our DEM here, because this is where the cross sections are from. I'm going to change this to clip to minimum and max under the symbology, and change the max to our BFE, 589.96. And then I'm going to colorize it. I'm going to make it red. And then I'm going to change my transparency a little bit. So this is where we calculate it. We calculated a BFE right here in line with the structure. And that BFE is only valid right here. That BFE is based on a slope, the slope that we calculated. And we only know that slope value basically from here to here. But it's only good for this line right here. So that's what it looks like. So this is that new BFE shown visually. Now, one of the things I do is I never provide this map with my BFEs. When I issue a single BFE with one cross section, it doesn't have a map on it, because if it did, I mean, I really would have to do more work to this. I would actually have to take this and buffer it to about 50 foot on each side to show, you know, not to give any false impression that that BFE reaches this far upstream or this far downstream, because it doesn't. It's only calculated right here. And what I do in my work, and I don't think I put this in the assignment, but I'll take a screen capture of that too. And I put it in the record. And you know what? It just helps me to see. If that way, like if I'm referencing something or looking back at it, I don't have to open up the QGIS application. I just go through that directory, and you know, quick two's in there. Can pull it up. I can pull up the NSS very quickly, and then I can actually pull up the map and take a look at the results. So that's pretty cool. But anyway, that's the walkthrough. That is doing a BFE. It would probably be quicker if I wasn't trying to talk and entertain. But you know, that's it in a nutshell. And then all the files for turn in. And you know, this is part of them, but it's not all of them. So you have to create the directory for the turn-in, for the references, and just use these as a reference to turn it in. You know, because I am going to be looking for the QML file. You know, it's not here. You know, one of the things I talked about was turn in the land cover, and I think we had a lot of problems with that. But what I'm looking for the land cover is, you know, basically all it needs to be is a similar area as the contours. And I think I put the contours in there as something I wanted to. So we can go to the raster extraction, clip raster by extent. Okay, so I'm looking at the national land cover data, the clipping extent, calculate from layer. Okay, I'll just use the same as the contours. Let's see what that does. I'm just going to try it, see if it works. There we go. And that's it. That's actually it, isn't it? I can't see it too good. Well, here's one thing interesting I noticed, because it doesn't match. It doesn't match this. You know, it looks like the contours are here, and that did something over here. So let me look at those properties. Let me look at my contours. Look at my contours. They don't have a projection on them. That's not good. Does that mean they're right? I think they're right. I mean, they're just not assigned a projection. I'm going to make sure they're assigned a projection. Because all the files, the contours were created from the DEM. The DEM is 17 north, so they're projected properly. So that's why I felt comfortable doing that. Now, whatever's happening on this extent clip for mask, it's putting a shift in there. So, but at the same time, it's still giving me that area. It's the same. Let me see if I can add. I'll add the style to it so we can make sure that it's lined up properly. And it is all the same values. So I'm comfortable with that. So I would save that to that same directory. And when I do this, it's zone 17. And it's projected. Let's see, make sure. Yep. So we're good on that. I would want to, now that it's in that same directory, might as well go ahead and, I don't know, if it depends on if you want to save this as a working file and then make a different one for your project, you know, of submitting all the files. But what I'm going to do is just copy and paste this. So we can clean it up. I never like to, don't really like to delete stuff. I like making new directories. So I think for the most part, you know, we can remove this now because that was the entire state. I don't think the direction and streams were part of the turn in. My land cover was in there. I'm going to remove that because that's not part of what was going to be turned in. Neither was this. Didn't include a DEM. And these are references off the internet. So the only thing we really need to do now is to put that style on there. I'm gonna make mine a little transparent. And I think we're pretty close. Let's look. Basin, contours, worksheet, land cover, location, QML file from the land cover. Oh, that's not in there. So mine's in my data directory. It's where I was keeping it. Right here. So I'm going to copy that and paste it in there. Nss results screen capture right here. QGIS project, QGZ file. In our case, it'll be this number 2. Basin square mile QML. Okay, so that's the style file we use for the basin in the program. Let's see. Okay, so I can't find it really easy. So look here. Make things easy on yourself. Use search. Okay, basin square mile QML. Copy. Walkthrough. Paste it. Okay, contour QML. Let's see. Same thing. Wow. Right here. Quick 2 results, got that. Cross-section shape, got that. Cross-section.xsc. So this is ready to turn in. So the only thing I didn't do that I want to verify is the contours. I don't think I used that. I don't think I used that style. I don't think I attached the style. So I want to make sure I use that. And I want to make sure I use the one that I just submitted. So I'm adding that on there. And then what was the other one? The basin. It did it automatically. So, but I still want to make sure that the style is from the one I'm submitting. So I mean, in my opinion, I think that's it. So that's the walkthrough. That's the walkthrough for doing a BFE, and that's a walkthrough for validating and submitting the files in the zip file. So what I'm going to do here, yeah, I'm going to delete this because it's just not part of it. I'm going to rename this. So this is how you submit it, and you just send it to a zip file. There's a couple different ways. Windows has a built-in one. I was trying to see, this is how you use the built-in Windows, send to compressed zip folder. I usually use this third-party one, 7-zip, and add to folder. So that's it right here. So I'm going to put it on my desktop because, you know, this is mine. I'm a bad speller, so that's probably not right. Proficiency. I think it's actually a couple odds in there, aren't they? Let's see how I spell it before. Bad. I'm bad. Oh, it's not on there. You're going to see what I generally do. Google always is, I mean, it's pretty awesome. Because I have to tell you, even though I'm a bad speller, it has to be spelled right. I mean, it reflects on your work. That's the bottom line. So that's it. I'm going to turn that in. And then to check it, look here, I'm going to extract it to this folder. Wow, it did it so fast I couldn't tell it. And I'm going to open up this QGIS file and see if it has everything attached properly. So this is my quick check to make sure that, you know, you're going to help out the teacher. Because now when I go to the cross-section file and look at the properties, it should say my desktop, and it does. So that's pretty cool. So I could email, what's neat about this is I can email that file, to people, and, a lot of people can take a look at it and review it and, open it up anywhere. And because the paths are relative, then it finds them automatically when they're open. They're in the same directory. There could be subdirectories to that project file. No need to complicate it. But that's really all I have. I mean, I haven't heard anybody. I'm curious to see if this thing recorded properly, because I don't even hear myself. So hopefully it worked okay. And does anybody have any questions? Okay, that's all I got then. If there's no questions, then enjoy your weekend and have a good day. And thanks a lot for coming. I mean, it means a lot to me. I like to have heard something, but it means a lot that you showed up. So, but I'll see you next week. And if you have any questions, feel free to contact me. Have a good weekend.